One, two, three. You know, when I imagine myself streaming, I think of streamers and YouTubers I like who are, funny and witty and original, who can speak with passion and emotion and flair. And then I get in front of the microphone and it's not that. I need to work on even reading stream chat properly. It's a little embarrassing. But from another perspective, I think the fact that I found this thing that I can improve at and that I care about improving, and that is basically the best case scenario for how to do admin of code, in my opinion. So I'm probably going to keep rolling with it for a bit. If you're watching this, if you're doing admin of code or anything else this month, I hope you're also able to get something meaningful to yourself out of it. Happy holidays. Thanks for coming to my TED Talk. Let's write some code. Again, I have not seen these problems. I've seen memes of them maybe, but hopefully that still means that I'm basically going to try to present an authentic, first time seeing these problems, solving them from scratch experience. I feel like we've done this before. Okay, so it's... look at the... Oh, I need to get 4. I'm just gonna look at... What? Oh. Just Vim things. Okay, so I wanted to parse... The cheapest way to parse in general is like just grab all the strings, but I also want to get the vertical bar location sort of reliably, so what I'm going to do is, I haven't even fully processed the problem, but there's like a right and a left and a right part. And we can use the classic ints function to just pull out all the ints as integers so that we're no longer dealing with strings. And we're going to use the structuring. And we're just going to use the same variable names for now. But let's see what the problem actually asks us to do. So left is winning numbers. Owned, I'm going to say, are the right integers. So for... are these both sets, I think, is the question. I'm not confident, but I think these cards should work with these being sets. So it's really just this. So this, and then we need to get the number of points. If it's non-zero, it's worth points. 2 to the power of, we double each time, so just 2 to the power of -1. Yep, that's just it. Okay. Oh, interesting. Okay. So the same winning, the way to determine winning is like the same, but... Oh, okay, that's actually... Wait, no. So it looks like there's some kind of winning each card propagates. So each time we win a card, that lets us win some number of other cards, and it's, the problem sort of implies there's no infinite loop, but if we do this naively, I think I will... Should I try doing this naively? Like, the naive way is, you just start by winning a card. Okay, so you start with one copy of every card, and the naive way is you just count the wins for each card, and whatever you like realize you win another card, you go and like depth first search into it, and that could be exponential time. But actually, so we could do it like topological sort to like make sure we handle each card only once. But I think quadratic should be fine. So what we're gonna do is we're gonna do a bunch of sweeps. Each time we keep track of how many cards we've won in the previous sweep, and then handle all those cards in the next sweep. And maybe this will be fun. Okay, let's take a look. So, how many? Yeah, that's fine. 212 is so small. This is a counter. So this is the initial. I'm just gonna do the same loop. This is an incredibly inefficient way to decide how many times we've won, but this is going to be a counter tracking card. Yeah, it's going to be a dictionary storing for each card number how many times we win it. So and we're going to do a sweep. So let's take a look. Let's see, yeah. Okay. It's actually fine. I didn't actually understand the. Oh, there's no such thing as points. Okay, I see. So count equals. So when we handle this card, we're going to add it in here. Yeah, there's no copying, right? All we're saying is that wins, you win plus equals 1. No, this is next wins. Count. And if this never happens, then it's fine. I have not tested this code. Is it too slow? Let's see. It's like a little cubic, but this should finish in, like, if there are no bugs, let me think. No, that's not true. I see, yeah. We need to not put things into next wins. That just actually infinite loops. We need to not put entries into the counter if there's nothing. Okay, that's still, So if my understanding is correct, it should, if there's no infinite loop, it should, like, no card can win itself directly or indirectly. Otherwise, that would just be an infinite loop. Okay, so there's a bug. Cool. But this is notably less than 212. So interesting. I mean, we can. Yeah, so you start with one of each thing. What's the bug? Yeah, I don't see it, so I'm going to. That's not even correct anyway. Okay, 9 is pretty bad. Do I not understand how it length is? Wait, I didn't read. Wait, okay, I actually just didn't read the problem. I see, I understand now. Wait, this is linear. Wait, what? What did I think this problem? Oh, okay. I clearly didn't read. Great. Okay. I solved a much harder problem than what's written here. Cool. So we can just do a rolling. We can just do it. We never see any card after. So this is just like a. I happen to know the number, so I'm just gonna cheat and put it in here. It's 1. Okay. Winning, and then. Count is wins card. No. 213 is 1 more than 212, so that the indexing is not off by 1. The 0th element of the wins will not be used. This is good for fewer bugs. Probably. For I in range. I have to be careful about off by 1s here. But I am, yeah, you need to add 1, and then add 1 to this as well. So for the next that many cards, all of them will have more copies. Count. What was that? What's that? It's totally wrong. Okay. I have sprinkles count. Sure. Cool. Okay. Yeah. As usual, I learned that I should read the problem. Sand filter. Let's take a look. So there's a fixed number of chunks. That's not too bad. Food production. Almanac. Seeds. Okay. I see. So for each seed. Okay. I see that there will be difficult. Let's see. So I think I'm going to use manual inspection to see if it's true that each map does just go to the next map, so that we don't have to worry about the map names literally at all. We can just ignore them. Cool. I believe that's true. So I believe I have paragraphs. And that means we actually just we can use ints. It's easier to chunks. Okay, so seeds. The first paragraph is the seeds. Take all the ints out. This number looks bigger than this number. Am I right? Or number of digits is okay. So. No. Oh wait, sorry. No, that's totally wrong. That's not how it works at all. Okay, so let's just map each seed through. For seed in seeds. LMap is my own eager map function, so that, and then what do I want to do? I want to chunk it. What is the function I have? Group of size exactly. How do you tab in my own text editor? So, okay, dest start, source start, range len, just to make sure I don't confuse those. Current is seed. No, that's for chunk. What is chunk? Chunk is such a bad name. Wait, this is, let me think about this. Chunks. Wait, what am I writing? This is total nonsense. This is, so for, sorry. Okay. It's a mapping. Each thing is a mappings. So for each mapping, I'm just, yeah, this is not gonna, okay. This is okay, this code is pretty rough, but it is what I want it to be, right? Take mappings. Each mapping is a sequence of events. You map it, you chunk it in threes. Okay, I think that's better. Okay, so if, and there are some off by ones here that are very nasty. So start if current minus, if it's true that this is less than equal to range len is, I'm going to be double checking here. So source 98.2 means 98.99. Yes. So 0 less than, yes, good. Then that we've successfully mapped, and we can break once is correct. And lowest location number log is this Python? But that's basically what we want. We want to take the minimum, so okay, what didn't work? Interesting. Oh. Man, you'd hope the type checker catches that. Okay, I'm ready. Part 2 is going to be interesting. Ho ho ho. Ho ho ho. I see. Oh, things are getting fun. Hi chat. Yeah. This is a fun, this is going to be an interesting problem. Okay, so each mapping is taking me like, you know, oh, that's not what I wanted to do. So for the first part problem, we just sort of applied each mapping by just going through each entry and searching for it. So that was, you know, like O of 200 things, but we cannot. That's, oh no, we're looking for, okay, we're looking for Lotus. So it's lowest. So it's actually just okay, that's interesting. Lowest. So I think you could do, I'm kind of brainstorming, I don't know the right solution. I think you could do is go backwards through these mappings. One thing I don't know is if these mappings are disjoint, like whether there might be one mapping where one range says to map like A to B, and then the later thing says to map A to B, but you ignore the second one because the first one takes precedence. If that were not true, we could try to work backwards. I don't know. With the obvious problem that the mappings are unlikely to be surjective, probably, you know. Interesting. Okay. Okay, so we're not let me count those digits. Yeah, we cannot do any seed by seed checks. Interesting. Okay. So working backwards is an option. I mean, it's like a pretty good. Well, actually no, that's really bad. Like you'd still have to search up to like the first. Like most seed numbers are not in any of these ranges, so you're gonna be searching for a while if you search backwards. So. Very interesting. So a framework of like the best solution I have in mind right now is you check each range, but not seed by seed. You go through the process, and at each mapping, you sort of keep track of, oh, like what's the next breakpoint? Where's the next time that like which range I go through in this mapping will change. Equivalently, like how many more seeds are there in a continuous range that will stay in like the same mapping, like submapping of every mapping, because within that submapping, it's the seed to final answer mapping is always like it's a linear. It's like it's a translation. It's like going up by 1 will increase the answer by 1. Okay. And that you could there might still be an input that's like pathologically exponential, but maybe this problem isn't. I don't know. I'm not. Oh, actually, well, okay. It's only exponential in the sense that I see. So what you do is just like you just sort of map the entire. You don't care if like there are like multiple solutions to this final thing, right? You just want the lowest answer in the image. So we're just going to take all the ranges and take each mapping in turn and map like the entire list of segments through that mapping and get a new list of segments. And I don't think this can be that pathological. Right? The only time a segment splits into 2 segments is when the segment like strictly contains a boundary of a mapping. So each mapping only increases the number of segments by at most 2. So that's still, it's like non-exponential. That's all we really care about. Basically any reasonable polynomial is going to be fine. And these are start in length. Very good. Okay, so we're inverting this. You don't need to sort anything until the end. We'll delete all that code. These are always start and in segments. I'm going to preemptively write this code again because otherwise I'll forget and have to debug. I write this bug a lot. Lots of people write this bug a lot. Okay. So what do you need to do here? We're going to find every boundary I should have kept this for loop. Okay, and then we're going to modify start. I see. So breakpoint is it's fine. Breakpoint is our line. This indicates that it's all in the same seg. Oh man, this is pretty. Man, I have to think. Okay, so the two possible, while true, I'm going to like find let prefix of start plus rlen that is preserved by this mapping. Okay. Right, sorry, preserved is not the right word, but is sort of kept together. I'm typing without thinking now. Okay, so what are the possibilities here? This is intense. Okay, I'm gonna write my cases, my two cases. There might be a third case. Does mapping, if mapping maps start to something, like if map maps it, break the seg. For start. Okay. Geez, this is intricate. Okay. So, maps start. We get a new segment. What is this segment? Source. Oh, this is offset equals start. Oh. This is so intense. Okay. Does that look right? That's not right. Oh no, I have to. Yeah, this is the remaining amount, that's fine. If they are right endpoints, therefore this is equality. Zero break. I'm not sure yet. It just means we've handled the entire segment. Otherwise, distort plus offset. Plus, what is the length here? So it's and does this make sense as yes, like this if statement is the breakpoint between when this thing and this thing. Is that right? No, that's not right. That's not. No. Yes, that's better. And then what does that update everything to? We've broken off this is very hard to reason about. I'm going to let the code do the algebra for me. Start plus equals segment length. Oh, we don't need to think too hard, but that's fortunate. I don't use this, right? I don't use this. Top cut. Should continue. Put that there, break. Oh, no, if source start larger than equal to start. I feel like this is going to have bugs everywhere. There's so many like pluses and minuses, but we're gonna see how it goes. This means that source start top cut is gets identity mapped. Am I in the right? Yes. Wait, this is not. Wait, hold on. At some point I switched. Oh dear. At some point I switched to totally switched representations. I want new segments to be start and length. and then do these both at the same time. Do you think there's any chance this is correct? Cool. It is not. Yeah, probably an infinite loop. I mean, I think we should verify this. Like, I assume, oh, it's negative. That's not good. It should not, that should not be happening. Okay. Just make sure. I should have printed. Yeah, okay, so it's not that, at least. What? Come on. Okay. Okay, so yeah, I'm doing this wrong. Start top cut. Is it just that slow? That can't be right. Okay, that's way too slow. Yeah, it. Oh no, I see. I'm not handling a break correctly. Oh, wait, I didn't. I see. I set this and then didn't do anything about it. Is this right? Yes, because it's handled. Is there any chance of that being? I'm going to test this. This is pretty low confidence. Still, I think it has a shot. Okay, that's good. That's good evidence. Oh, I'm pretty surprised I didn't do anything wrong here. Okay, but onward. Wait for it. Some racing thing. Time, distance. Oh, yes, I remember. I remember seeing a meme. Oh, wait, there's only... What? Really? That's... Oh, interesting. There's... Oh, okay. I remember seeing a meme. High level 51. I remember seeing a meme with the quadratic formula written on it. And... I tried not to think very much about it. I'm still not going to think very much about it. I mean, my prediction ahead of time was like, you just brute force it'll be obviously easier to code. Unless like it's an extremely difficult problem for day 6, or difficult at least like mathematically involved for day 6. But I don't think this is that. I mean, oh well, I forgot. This is part 1. That's fine. Okay, times equals int day dot line 0 distances. And we want to accumulate the product for sort of hashing reasons, I guess. So for t0 in t is 1, it doesn't, it's fine. Ways 0 ways plus equals this thing greater. Do you have to beat it or tie it farther? Just kind of do that. Wait, why did it not work? Oh, I didn't submit the answer. Hi, thanks for, well, I don't know actually what the right reaction is. Thanks for using channel points. Yeah, that's fine. Haha. I see. How do I get, you know? I can't be bothered to do input parsing. I see. Yeah. No, I'm still not going to use the quadratic formula. You just okay, so if you search the middle, this is this is a like math fact, or there's like some rounding, but this is the furthest you can go. This choice for how long to press the button is the furthest you can go. We're just gonna search twice. I'm gonna do this twice. There's no reason to, that's fine. We're gonna do this, we're gonna do that. And then we're gonna not off by 1. Is this correct? I'm like not thinking very hard. Okay. What did I do wrong this time? Wait, wait. No, that's. Oh yeah, it's because I didn't switch these two. Because I need to switch these comments. Yeah, okay. I should test it for these two. Come on. Do I have times like 10? 7.56, that's correct. Wait, really? Dang. Oh, I'm really... Wait, what? That's the dumbest mistake you could possibly make. Wait, did I even... Oh, wait, I didn't actually get the right answer. I just saw the number on the page. I was like, that's correct. And it's not how it works. Okay. This time, I said 25 seconds. Okay, I'm gonna double check because that serves me right. That is actually the number I want. I can submit that. I swear to God. Okay. And 7. Wow, we're playing poker. Oh, does brute force work? Maybe it does. I guess numbers aren't... Oh, I see. Like it's O of this, not O of that, huh? Okay. Well. Oh, okay. Yeah, I don't know. Oh, yeah, yeah. Okay, so the quadratic formula did meme. The quadratic formula meme did anger me to be like, you can't just do it. That would be too slow. It's not. Anyway, I hope that was entertaining though. Okay, I don't know if I actually stated what I'm doing, but I'm picking up the time that I know is far enough, and then binary searching both above and below to find the range of times. This is so stupid now, thinking about it, but it's fine. But I binary search both below and above to find the lowest possible and highest possible time that I could be spending pressing the button to go far enough, and then those give me the endpoints of the range I care about. Anyway. This is gonna be some work. I need to get... That's not right. 6.pi. Did I actually say? Yeah, so I need to repeat what chat says for the video. Chat says that I could have just run the same brute force and it's fine. And it is fine. What was I doing again? Yes. Creating an input file. Looking at my A7, we have 1,000 hands for hand bid equals Okay, so this part is explaining that we don't have to think about like actual poker. Like we don't have to compare the like figure out which four of a kind is. We just have to order them lexicographically ish, but not exactly. Okay. Let's see. Oh, there are no straights. I see. So it's just okay. That's fine. That's really easy. Let me think a little bit about two. Yeah, I'm pretty sure we literally don't need to think about the rules. So we just do some countering and then it's fine. Hand counts is it's a values list, and then we're gonna sort. I need to do that. First equals true. This is literally the sort key. The thing we do need though is that this thing. Oh, that's not right. And we want to reverse this, so it's why is pasting wrong? We need to do okay. Ranks equals what are we gonna put here? We're gonna put a tuple with the first thing is counts, most important. Then let's not race index C for C in just hand. And then the bit, I guess. And then okay. Multiply by its rank. And so sort. Is this valid? What positional? Oh, it's a tuple. I forgot about that. For rank. Oh. I'm using some bad variable names. Okay, I'm going to test this because that looks so similar, but it's wrong. Okay, why is it wrong? How do you even get numbers that like slightly wrong like that? How are you 200 off? What mistake makes you it's probably not actually how this works. Wait, whatever. No, I do want. Oh no, I don't want to reverse them. Oh, wait, is it true? Okay, I see. I didn't actually want to reverse them, which means we just want to do that. Oh no. Okay. That's Hurrying. That's fine. It's not actually that bad. We're gonna do that. We're gonna fix the ranking. What's the dumbest thing we can do? The dumbest thing we can do is just literally try every Joker and take the best count that appears, which we're gonna do that. And I have to. Like, if they give me, I hope they don't give me, a hand of 5 Jokers. They might. This is clearly actually. Cartesian is a utility I wrote, but it just, I think it's something, iterative rules or something. This is so funny. Why is this? There's no way this works. I should test it. Okay, it's wrong. Great. Oh, I didn't put real hand in here. Oh. Splat operator in the wild. Okay, too low. Yeah, I don't know. Splatting's great. Okay. Oh, this is wrong. That's total. Yeah, the test case isn't very strong. It wouldn't catch this kind of thing. Is that in fact? Why did I print so much garbage? Chat says big Splat fan. Yeah, I like destructuring and undestructuring. Yeah, I do want to make sure. I think I want to know that it's like get one bit about whether this is correct. Yeah, it looks like it should be in the right. It's in the same ballpark. Okay. Yeah, it's fine. Cool. And that's all the puzzles we have for now. So see you in a few days.